Hello, welcome back. I just want to take a quick look at some of the recent data trends and then see how that applies to our Matlab model and then talk about where we go from here. So let me first of all do a little screen sharing of some of the recent data. Okay, so here's the link that I have. I remember I put useful links in the classroom. And so here's the New Jersey sort of official data hub. And what I've been using for our data point for deaths is the total confirmed deaths each week. So you'll see on the other link that I gave you, the deaths for New Jersey is actually the total of these two, the probable and the confirmed cases. But the magenta data points I've been plotting are just the total confirmed deaths. But what is interesting is actually to look at the census data from hospitals. That's probably the most reliable data we have because we know how many people are, every hospital every day is reporting how many patients they have who are being treated for COVID-19. So first of all, if you look at the overall trend in hospitals, obviously it's nice, it's good, it's kind of matching what we expect our infection curve to be doing. But if you look closely at the end, we've been bouncing around. If you look daily, we had actually gone below 1,000 by just a little bit, and then we've been bumping around 1,000. So over the last week or so, or maybe even the last 2 weeks or so, we've been down near 1,000 for a while. Actually, we were up closer to 1,100 on the 25th of June. And then we went down, down, down. So we finally got under, into the thousands by the 27th of June. And then it went down below 1,000 in the 28th and 29th. And then on the 30th and onward, we bounced a little bit above 1,000. So the question is, have we reached, I'm assuming that the hospitalizations are relatively proportional to the number of infections. So with the hospitalizations sort of bouncing around now, around 1,000, it's possible that we've reached a bottom. Not necessarily the case, but it's possible. Now, on a more optimistic note, if you look at ventilator use, which would be for the most severe cases, that has continued to drop every day. So even if you look at that, while the hospitalizations did tick back up, ventilator use did actually drop during the same time. So it means that people are getting to the hospital, but are not as many severe cases are in the hospital. Although those numbers are just slightly lower. But we're at 5.4% of our ventilator capacity. That was a major concern early on. There's some questions about how efficacious ventilators are. It seems like only 10 to 20% of people who go on the ventilators end up recovering. But still, I would rather have a ventilator than not. Probably also eases the suffering of those who do end up succumbing to COVID. Our intensive and critical care numbers seem to be dropping pretty much every day. So 216 is the lowest that it's ever been. So once again, that indicates that people, those would be people who have severe cases. So it seems like the number of severe cases continues to drop slowly, but the number of people showing up in hospitals has actually sort of leveled off and is sort of bouncing around the 1,000 mark. So we really need to keep an eye on that hospitalizations number as well as ventilators and intensive care numbers, and to get a sense of what's really happening in terms of the number of people infected and where we are on the curve. But it looks like maybe we are somewhere near the bottom at this point. Now I have a couple of theories of why there might be a slight bounce right now. We are just a few weeks out from the major protests. So we would expect some people would have gotten sick because of that. So when we're looking at 1,000 hospitalizations, it's possible that with the thousands and thousands of people who protested, maybe a couple hundred ended up going to the hospital for COVID. So that's one theory. Probably a more compelling theory would be that the beaches are open. And more people are going down to the shore and the local establishments down by the beach. So that probably had a bigger numerical effect than the protest, because that's going on every day, and probably will for the rest of the summer. New Jersey really can't afford to close its beaches unless things are just awful with the pandemic. A third possibility is that maybe some of the people who were infected early on are reinfected, but right now we don't have any evidence for that. It would make sense that eventually people could become reinfected, but as I read the papers about that, it seems like, at a minimum, people would be immune probably for about 3 months, and it probably is more like a year that people are immune. So there may be anecdotal cases of people who think they've gotten it a second time, but the epidemiologists don't think so far that a significant portion, that it would be a significant effect of people being reinfected. So now let's switch over to Matlab. Whoops, I think I'm still recording here. So sorry about that pause. The first thing I did is I updated in Matlab the last couple of weeks of data for deaths. Okay, a really good thing about this is the number of deaths is really dropping off. So what I want to do is look at what happened from week 22 to 24, and then week 24 to 26. It's probably better to look at a couple weeks at a time in case some of the numbers are slightly off. So if I take the number of deaths at week 24, which is 12,889, and subtract the deaths at week 22, 12,049, and divide that by 2, there were about 420 deaths per week from week 22 to 24. We're now up to week 26. So that would have been about, if we were looking at a period of a month going back from now, that would have been about 2 weeks ago, or the beginning of the month, if we're counting from now. Whereas if we look at week 24 and week 26, we would have, using the same methods, 13,251 deaths minus 12,889 deaths over a 2-week period. So we're down to 181 deaths per week in this 2-week period. Okay, so if you look at that, that's less than half. So we're, things have gotten better and better, and now we're far better at the end of this month period than we were at the beginning of this month period. Okay, so that's very optimistic indeed. All right, so let's look at matching the deaths to the plot. Okay, so I've actually changed the numbers already, but let me go to the plot for deaths, and let me go down to just 0.002, so 0.2% of the population, and let's look over a 30-week period. And we can see the magenta data points, and our curve that we're modeling with is matching that very well. So I've taken the A values. I'll share this code along with the video, so you can just copy it. But I've updated A values through week 24 to match the data. Okay. Now everything after that is pure speculation. So we want to see what happens, but it's not wild speculation. If at week 24 we're at an infection coefficient of about 1, I would expect that the government is going to continually loosen and raise those infection coefficients. I have them going up every 2 weeks by 0.2. All right, up to about week 39. Okay, so up through week 38, these represent summer weeks. All right, week 39 is when school starts. So I put a bigger jump in week 39 to see what would happen. But we just have a slow easing of the coefficient That means we're doing a little less social distancing all of the time, which means we can do things like possibly eat in at a restaurant in a couple of weeks. So, but as we do things like allow restaurants to serve outside, we would expect the A value to go up, but hopefully it'll just keep going up slowly. Now, what are the consequences of that? Well, let's see what happens over the course of a year. I'll go up to 60 weeks, so it's a little beyond a year. So let me actually switch to plot choice 6 as well, so we're showing everything, right? So remember, the white region is what's already happened. The shaded blue region is what's going to happen, and I added a dashed blue line at week 39 because that's when school opens, okay? So if we look at when school opens, first of all, let me just show you in the code how I added that dashed blue line. It's just in case 6. You'll get a copy of this code, but right here, all I did is I connected 2 data points, okay? So the X value of both at the bottom of the line and the top of the line, the X value for both of those points is 39 weeks. And the Y value for the bottom point is 0, and the top point is Y max. And I put in a dashed blue line. That's what the dash dash B is. So that little line of code put in a vertical line for when school starts. Okay, but let's look at how this plays out now. So if we're looking at deaths, we can see that after school opens, the death curve, which had been rising very gently, does go upward. It has its slope curves up a little bit faster after that because we would have relaxed things a bit for school to open. Let me go up just a little bit higher. You can see that while it does go up, let me go, Y max is now 0.002. Let me go up to 0.005. Okay, it's not going up drastically. So it looks like, you know, we're at week 26. Most of the deaths have already happened. Okay, so we will have more deaths over time, but the rate at which people are dying has gone way down. It probably will go up a little bit if we open up schools, because that'll have a fairly significant impact on the transmissions, but it won't be large compared to what was happening back in March and April. So let's keep scaling up. So if we go up to about 0.15, or I'm sorry, 0.15, we can now get a good look at the infection curves, right? So we can see the initial, the peak of the pandemic for us was, you know, there around week 16 or so. So that was in April. The curve has been coming down, down, down. We're probably nearing the bottom of it. I don't know if we have hit the bottom. We might have just a temporary uptick here with those hospitalizations, but we probably are near the bottom with the numbers that I'm using. The curve will, you know, eventually kind of curve up a little bit. It's pretty flat until school starts, and then because I allowed the coefficient to go up to 3 when school starts, it does tick up a little bit from there. And we will have a peak of infections in the latter part of the year, probably in early December. We'll have a second peak of infections, but it will be, you know, very, very small compared to where the first peak was. So our hospitals should easily be able to handle the number of people who will be coming in during that period of time. If we go up a little larger on our scale, we can see other things. Up to 1.1, I'll go all the way up. We can see what happens to the susceptible population. And so that's the blue line. The number of susceptible people dropped drastically through April. It's slowly coming down throughout the summer as more and more people have become immune. And but then it's dropping, you know, it'll drop more rapidly once school opens and we kind of open things up a little bit. We would expect it to drop faster. And then the flip of that is the number of people who have recovered. So a lot of people were recovering quickly during the peak of the infection. We're at a point now where people are, I shouldn't say recovered, but have been Yeah, I guess they've recovered their immune. The immune population is slowly growing throughout the summer, and it will continue to slowly grow once school opens. And it looks like, it grows at a slightly faster rate because the infection rate will go up slightly once school opens. So interesting numbers to look at is how many people are immune right now. So if we look at the recovered population at week 26, remember there are 100 time steps per week, so that's why it's 2,601. Looks like we're at 59.56% of people being immune right now, according to our model. If we look at what would happen at the beginning of school, that'll be week 39, so 39 with 2 more decimal places, because we're doing time steps of 100. Looks like by the time school starts, 66.54% of the population would be immune. All right. Experts will put herd immunity around 70%. So we basically should have herd immunity when school starts, just a little bit shy of that. So then if we follow that out over the course of the year, by the time we get to the end of the year, another 10% of the population has become immune from the time that school opens up to the end of the year. So it just, fewer and fewer people will be susceptible to getting sick after that. So once you get past the 52-week mark, it's, a lot of the population has already become immune, and it's going to force the spread of the virus will drop off precipitously, even though we have A values, coefficients of transmission, that are going up continually. Okay, they'll probably peak at around 3.5 because that's just sort of what would happen naturally, maybe 4. So it doesn't make a lot of difference if we keep raising that number once school starts, as long as we kind of do it slowly. So I would expect at the beginning of school, whether you're if you're at Wilberforce, you'll try to keep the number lower by doing things like eating lunch in the classroom instead of everybody going to the NPR. I would imagine if you're at college, you probably would, go to the dining hall and sit by residence hall, as opposed to just mixing everybody together all the time everywhere. They're probably going to do things to try to limit the groups that you're in. So there are things that they can do, and if 3 would be pretty generous. Maybe you do sit in class wearing a mask if you're in a big college lecture hall, but you're probably going to still get to go to class if you're in the New Jersey area. When we apply this model to other states, we're going to see it's not nearly as optimistic because the number of immune people must be very, very low in states like California, Texas, and Florida, which are having a rough time of it right now. So we'll talk more about that on Monday at 11 a.m. And maybe some of you will take on trying to model some of the other states. So I'll hopefully see you on Monday.